Hello everyone, I'm Shruti from CSE AML and currently pursuing my BTech first year in Institute of Aeronautical Engineering, Dundigal. Today, my topic is about simplified calculation of coverage area for MF AM broadcast stations. Let's see the topic. The first slide is about the introduction to MF AM broadcasting. What is MF AM broadcasting? MF, medium frequency range, which range up to 300 kHz to 3 mHz. AM, amplitude modulation. Carrier amplitude varies with the audio signal. Typical broadcast frequencies. It's up to 530 to 1700 kHz. Used for regional and national broadcasting, especially in the rural areas. Then the next slide is about the modes of propagation. MF propagation mechanisms. There are two types of MF propagation mechanisms. It is ground wave propagation and the sky wave propagation. The ground wave propagation dominant in MF band during the daytime, follows the curvature of the earth and strongly affected by the ground conductivity and the frequency. Next, it's about the skywave propagation. Occurs mainly at night due to ionospheric reflection. There are two layers in the ionosphere, which are denoted by E and F layers. Enables long distance reception, and it takes up to hundreds of kilometers. The ground wave propagation is mainly done in the daytime, but whereas the skywave propagation is done in the night. The next slide is about the key factors affecting the coverage. The factors influencing coverage area are transmitting power, frequency, ground conductivity, antenna efficiency, and the receiver sensitivity. The first is about the transmitter power, which is denoted by the capital P. Higher power gives rise to greater field strength. If the power increases, the field strength also increases. Next, it is about the frequency, which is denoted by the small f. Lower frequencies propagate farther. Ground conductivity. High conductivity, like seawater, improves ground wave range. Next, it is about the antenna efficiency. Depends on height relative to wavelength. Next, it is about the receiver sensitivity. Determines minimum detectable field strength. The key factors are transmitter power, frequency, ground conductivity, antenna efficiency, and the receiver sensitivity. So the next slide is about the field strength and distance relation. Field strength versus distance. Field strength decreases with distance due to attenuation. The empirical formula for ground wave field strength. The formula is E equals to 300 root P by D into E power minus alpha D, where E stands for field strength, which is measured in MV by M. Then P stands for power in kilowatt per hour, where D stands for distance, which is measured in the kilometers. Alpha stands for attenuation constant, which depends on the frequency and conductivity. Then The next slide is about the coverage radius estimation. Simplified coverage radius calculation. To find service radius capital R, where field strength drops to a minimum usable level. Example like 1 MV by M, where capital R service radius is equals to K into root P by E minimum, where K equals to propagation constant, which depends on the ground type or frequency. The service radius R is equals to K root P by E minimum. The next slide is about the P equals to transmitter power, which is in kilowatt per hour. E minimum is the minimum acceptable field strength. Let's take the example for service radius R. For 10 kilowatt AM transmitter, ground constant K is equals to 300 and E minimum is equals to 1 MV by M, where service radius R equals to 300 root 10 by 1, which is approximately 949 kilometers, where actual range may be up to 100 to 150 kilometers due to losses. Then the next slide is about the example calculations. Example 5 kilowatt AM station. They give power P equals to 5 kilowatt. Frequency is equals to 1 megahertz. Ground conductivity equals to 5 millisecond per minute. Minimum field strength is equals to 1 MV by M. The steps for standard charge, K is equals to 250 for 1 megahertz over average soil. Compute where the service radius R equals to 250 K into root P by E minimum, where K is equals to 250 and root P is 5 and by 1, which is equals to 559 kilometers. Considering practical losses, it's up to 80 to 120 kilometers coverage radius. The next slide is about the nighttime coverage and interference. Skywave coverage at night. At night, ionospheric reflection extends coverage beyond 500 kilometers. However, co-channel interference increases from distant stations. Regulators set nighttime power limits to prevent interference. The next slide is about the practical considerations. Practical factors in coverage planning. Terrain. Mountains and buildings can reduce signals. And the ground conductivity maps used for regional planning. Antenna placement. Avoiding obstructions improves uniform coverage. Regulatory limits. Power and frequency assignments for national authority. For example, ITU, FCC, TRAI. Let's conclude the topic, the summary and the final insights. Simplified methods help quickly estimate MFAM coverage area. Actual coverage depends on the terrain, ground connectivity, power, and the frequency. For precise results, use ITU or FCC propagation curves and measurements. Understanding simplified coverage calculations helps engineering plans optimize and troubleshoot AM broadcast systems effectively. Let's take a quick recap of the session. The first slide tells about the introduction to the MF-AM broadcasting. MF means medium frequency range and AM means amplified modulation. MF ranges up to 300 kHz to 3 MHz. Then the next slide is about the modes of propagation. Then there are two types of propagation. One is ground wave propagation and the sky wave propagation. Then the key factors affecting the coverage area, like transmitting power, frequency, ground conductivity, antenna efficiency, receiver sensitivity. And then it is about the field strength and the distance relation. The formula is E equals to 300 root P by D into e power minus alpha D. The next slide is about the coverage radius estimation. The service radius capital R is equals to K root P by E minimum. Then it's about the coverage radius estimation. It's an example for coverage radius estimation. Example calculation. Next, it is about the nighttime coverage and interference. And it is a practical considerations like terrain, ground connectivity, and antenna placements and regulatory limits. And it is the conclusion of the topic. Understanding simplified coverage calculations help engineers plan, optimize, and troubleshoot AM broadcast systems effectively. Thank you.